Figure shows a metal rod PQ resting on the smooth rails AB and positioned between the poles of a permanent magnet. The rails, the rod, and the magnetic field are in three mutual perpendicular directions. A galvanometer G connects the rails through the switch K. Length of rod is equal to, so L is equal to, here L is equal to 0.15 meter, B is equal to 0.5 Tesla. Resistance of the closed loop containing the rod, so R is equal to 9.0, right? So 9 into 10 raised to minus 3 ohm. Assume the field to be uniform. Suppose K is open and the rod is moved with speed in the direction shown. Give the polarity and magnitude of the induced EMF, right? So when key is open, only current is maintained by the rods, right? So here rod means here the current is flowing. P shows as a positive charge and Q shows as a negative charge. So this end P act as a positive and Q act as a negative. So current flowing from P to Q. Now second question, is there an excess charge build up at the ends of the rods when K is open? What if K is closed? When K is open, that charge provided, right, by the rods, but when K is closed, K is open, so when K is open, excess charge will be both ends of the rod, and K is closed, the charge provided by continuous flow of the current. So next question is that with K open and the rod moving uniformly, there is no net force on the electrons in the rod PQ, even though they do experience magnetic force due to motion of the rod. Explain. So see here, because of so much excessive charge on P and Q on the rods, magnetic force will be cancelled by electric force, right? So here P and Q both have excessive charge, so magnetic force will be cancelled out by electric force. Now we have to find retarding force. Retarding force formula, that F is equal to Bill. We don't have I here, so I is equal to E upon capital R. Now E is BVL upon capital R, so I is equal to B 0.5, V that is 0.12, and L 0.15, right? So 0.5 into 0.12 into 0.15, that is 9 into 10 raised to minus 3. So that is our I in ampere. Now we have I, so F is equal to B 0.5 into 9 into 10 raised to minus 3 into L is 0.15. Okay, so here to find current, I didn't divide with R. So first we have to divide with R. So here in the last value I have to divide with R, and that R is 9 into 10 raised to minus 3. So answer is coming 1 ampere only. So here it is also R. So I is equal to 1 ampere. Now putting that value in force formula, so 0.5 into 1 into length, that is 0.15. 0.5 into 1 into 0.15, so that is 0.075. that Newton is the magnitude, that is force, right, retarding force that we have 0.075. Now next question is, how much power is required to keep the rod moving at the same speed when key is closed? How much power required when key is open? See, when key is open, power will be 0, right? So when closed, P is equal to, that formula is F into V. So F is 0.075 into V is 0.12. So into 0.12, so that is 9 into 10 raised to minus 3 watt. So this is the power. Now next, that is how much power is dissipated as heat in the closed loop. So that dissipated power is I square upon R. Now I is 1 and R is 9 into 10 raised to minus 3. So power dissipated P is equal to 9 into 10 raised to minus 3, and that is what? So what is the source of this power? Source of that power is external agent. External agent dissipated that power as a heat, right? So whatever power we get, we can use that 50% of that power is also dissipated. So 50% we can use and 50% we can't use. Last question is, what is the induced EMF in the moving rod if the magnetic field is parallel to the rails instead of being perpendicular? So here EMF will be 0, right, because of no potential difference. Why? So EMF will be 0 because here magnetic flux is not changing. So when magnetic flux is not changing, induced EMF we can't give. So magnetic flux is not varying.